What's up, y'all? This is a quick robot explanation for our V1 MOA robot. It worked pretty well, but we did end up rebuilding. If we hit 300 subscribers by the end of this year, we'll do an explanation of that. But right now, an explanation of our robot. So starting off with the intake itself, this is a intake initially designed to not have any chain on it whatsoever. In high stakes, we had our chain snap, and we wanted to have a design of as much consistency as possible. So as you can see, every single one of these intake rollers is geared together on the overall S design. So the way it works is we have this motor right here. That motor is connected to this piece of Delrin, and that Delrin goes like this. Has a gear, and this stage runs at 720 RPM or 900 RPM, and this stage runs at 720. It's pretty fast, as you've seen from the videos. And we also have another piece of Delrin here to keep it to prevent from being canty. What we had happen a few times is these gears would skip in here, especially this one right here. So to prevent that from skipping and these two from skipping, we added this piece in here. I can pop up the CAD right here so you guys can see how it was designed. Other than that, we did rubber band rollers for everything. We liked them because they were very light and they're very flexible. So essentially, when it comes to tuning and building an S-Bots intake, the biggest thing that you got to do is tune the compression between the bottom stage and the rollers themselves. So you want to have as little compression and still have it work. It actually, at some spots, it may seem like there's a dead spot, but what actually happens is when the intake rollers spin at 900 RPM, these rubber bands expand outward a tiny bit, and that's what it keeps it going. And you want that, because when you have 12 balls in this intake, you want the rollers to keep moving. We do the same thing up here, except it's with 60 to 60, and these are all 36s. Now this bot looks like an absolute chonker, but it's actually very light, and it's really fast as well. If I drive it around, I only have one hand here, but it's really fast. One of the reasons we did rebuild is because of the fact that this was so short. We'll go into the drivetrain later. Now the last thing is this aligner right here. We used to have a piece of seat channel on the back of this robot. You can see it in our first YouTube short, which was pre-MOA, where we had a piston hood type of a thing. And we used to just have a piece of C-channel because we didn't think that aligning was as important. So we ended up removing that and then moving the last roller inwards a bit and adding this aligner. The reason this aligner is very important because we can do some really cool stuff. So if you're like this, you just drive backwards and we align with the goal automatically. So no matter where we are, even if we're like this and we just drive backwards, we're just aligned and we can immediately score. That really helped a lot, especially when we're under defense, so we can score, and it allows us to score and then quickly hook with the descore arm. Now, when it comes to mid-goal scoring, initially when we designed this bot, we used this right here. Essentially what we do is, this is two pistons on this C part. We would intake balls. Right now the bot's half broken and half taken apart, so the pneumatics don't work because we removed the tank. Essentially, this ball goes over here, and then when we'd have a bunch of balls, we'd outtake a bit, and then we just lift this up, and then we could score mid-goal. But the issue with this was two things. One, we didn't anticipate that this roller had to be any higher. It was a bit too low, so it would score, but you had to be lined up within half an inch, which is not the best for driver and auton. So what we actually ended up doing is we figured out that you can just score mid-goal from the top, because this hangs downwards and the ball just falls out. So I think it's in one of our autons that we posted, where we can just score mid-goal from up here, and that's what we ended up doing later in the season, and we just banded this down and never use this again. But that's a pretty cool novel concept. Another cool thing is that to have S, I wanted the bottom to be as low as possible so we can fit all the balls in a S. So these pieces of Delrin over here do a lot. Not only are they the places where all these gears rotate, we also have two motors in here. So one of these motors is attached to the intake, and the other motor is actually attached to the drivetrain right there, and has a shaft going under through there. And then this piece of plastic is not only a sled, but it also prevents the drivetrain gear from being cantilevered. So that's what that does essentially. Other than that, you can see it's kind of broken. Oh yeah, let's go to the bottom of the drivetrain. The bottom of the drivetrain also did have a bunch of evolution as the bot was like built. Since the bot was built, we used to have a lot more bracing because of the back cross brace, but since we got rid of that, it is a little bendy, but it really doesn't bend at all because we ended up adding this piece of 3-wide. But we used to have 2 add-on pods. We had to get rid of one because we wanted the aligner here. And we actually didn't really end up using this towards the end of this bot, but we did use it here and there, especially in skills. This is a pretty cool pod because it is geared. The only reason we gear this is because there's no way to fit in an add-on pod in this thin of a drivetrain, because you need the space for the sensor and next to the add-on pod itself for contacting the ground. So if you want it to be thin, we need to do it geared. We didn't see that it didn't really change or make it any more inaccurate, and it worked really well. So if you guys do have a really thin drivetrain over here and you want to do an add-on pod in there, definitely recommend, or just do leaf spring. But this worked incredibly well. So that was our add-on. Now we also do some cool bracing. We initially started doing this because me and Sohail from 2915V, he's from New Zealand, we designed a bot together in high stakes with this type of bracing, and it's honestly like really strong. It's stronger than just having a single 3-wide, and it's also pretty damn light because all these are nylon. And the thing is, even though they're nylon has pretty good compressive strength, so it doesn't make it any weaker. And it also just allows, that's why we don't have a wheel in here. Now, an issue that we saw with this is our drivetrain was very short, so like when it came to like tipping over, we could just like go forward and tip like that. Now, to prevent that from happening, I just pressed this down, and we never tipped in a match. However, it just makes it harder to drive. So when it comes to like this robot, we did some changes, which I'll talk about when I make the explanation video. Other than that, some other cool parts of this bot would probably be this hood. I'm sure you guys have seen the YouTube short where like we score and then descore. This did a couple really cool things. One, it scored the balls into the goal. It can't score right now because we've harvested all of the chain off the bot, but if I did add the chain back, this would rotate and it just scores the balls on there. And the cool thing about this is you'll see lots of the AKV1 robots, they'll have this, but they have it pistoned up and down for them to descore. But we don't need to do that, because what happens is, this is like very into the goal, but when we have a ball here, this doesn't really have any banding, so it kind of just bounces up and down. Eventually, like in a knot-on, it will go all the way like that. But when I'm trying to descore, what I do is I just score, and then since it has no weight, I can just pull off without pulling the ball backwards, and then I can just ram in and I have a really good descore. So, and because of how much it goes into the goal, it was really good. And since we didn't have this descore until our last competition, it worked out really well. Other than that, we also have a hook on this bot. In general, when you're designing your bot, I didn't realize that for our last bot, but you want to make it like as wide as possible, which is why this hook was really good. So that way your hook is shorter. It has like more torque and it's easier to go in and out of the goal. So it's just a standard hook. Worked really well. Probably throw up some descore videos. We also did have like mesh on the side here to prevent the balls from going left and right. Same thing in here. Same thing down there. Other than that, oh yeah, one really cool thing. We call this the pooper mech. Right now it isn't zip tied properly, so it's like that way a bit too much. But essentially this would be like this. And every time we would see a ball with a color sensor right there, an optical sensor, we removed it. This piston would open. I'll throw on a clip of it. The piston would open and we'd color sort the balls. And this is really good because unlike most color sorts that we have more like ball capacity because we don't know how to hold the opposing balls until like we score. And also like when we're going around the field, I don't need to like care about what balls I'm picking up. So every time we're scoring in the goal, it's always the right color, even in the mid goal, because we color sort before our mid goal scoring. So some teams use mid goal scoring to color sort for the high goal and vice versa. So we don't know how to do that because we have this before anything else. The reason it is so wide itself, the bracing initially, is because you see all these motors. Unlike most other robots where the motor sticks out, these ones don't. And there's two reasons for that. One, we don't want to like ram into it, and two, because we wanted the balls to be so low here. If I wanted to do a stacked motor here, that would be like right above over here, and this was down like this, so I couldn't have a stacked motor and at the same time have balls coming through in the middle this low of the bot. So that's why we wanted the motor to be more into the bot like this way, and this is the only way I was able to achieve that, and it did work out really well. So that's good. And there are many gears on this, but the intake friction was actually incredibly low. Like, you can see how easily I'm spinning this with just one finger. So same thing up here. I guess the last thing would just be the smash loader, standard tipping. We like did lots of experimentation and then finally came up with this towards the end of the bot's life. I think that's pretty much it with this bot. Oh yeah, we also have this over here. This was just to keep the balls in. Just one little piston. And I think the last thing, oh yeah, we had like 6 distance sensors, no, 5 distance sensors on the spot. We mostly just used the one that was forward. It was like attached like somewhere up here. It just looked this way. So we would, when we're driving to the wall to like mash road, we just drive until it sees that distance with like PID. I think that's pretty much it. Thank you for watching. Make sure to subscribe if you guys want to see the robot explanation of our newer robot, which is a lot better.